So as we continue to introduce the main ideas that get us started with chemistry for the year, one of the things I need to tell you a little bit about is how we handle math in chemistry. There's a lot of calculation that goes into a fair amount of what we do in chemistry class, especially second semester, but some right away at the beginning of the year too. And how we round our answers, how we make measurements into good answers when we do calculations with our measurements, all falls under the sort of the hood of significant figures and what significant figures are. For most people, they've never heard of significant figures before they get to chemistry class, and so it's important for us to start out talking about what significant figures are and how we use them. So there's something new to learn about how you round your answers, essentially, is the long and the short of it, and how an accurate answer or an accurate measurement and a precise measurement can be used to the best of their ability, or how we can make the most of a good measurement in our calculations. And that all falls under significant figures. So I'll tell you a little bit about what those rules are and how rounding works. We're going to start with addition and subtraction before we even get into what significant figures are, because it turns out that for addition and subtraction, the significant figure rules actually don't really apply all that much. So I'll switch over to this and show you a few examples of basic adding and subtracting. For the most part, this looks very elementary, like something you probably haven't really looked at or done for quite a long time. Taking numbers and lining them up in columns like this isn't something that we do a lot of in high school math classes. And we aren't going to do a lot of it in chemistry either, but it's the easiest way for me to show you how we determine the answers that are best. So in the first problem here, we've got three numbers lined up. And before we do the math and actually start adding things together, and certainly you can use a calculator for this as well, and I'm just going to do it here on the screen, we need to look at the rule at the top of the page here. It says for addition and subtraction, round your answer so it has as many decimal places as the original value with the fewest decimal places. What this basically means is that the weakest original number, in this first example we have three original values here, the weakest of those is the one that determines how strong your answer can be. You've heard the old phrase, a chain is only as strong as its weakest link. Same thing's true with math. If you have one very weak measurement among a bunch of strong ones, then that weak one is what limits the quality of your answer. And the same thing's true with numbers here. And so when we look at the example that I've got for you here, we've got 0.50, 410.05, and 9.67412. Now, what you want to look at in adding and subtracting is how many decimal places each of these values has. And look for the one that has the fewest. That will determine our answer's decimal places. So I've got 0.50. Obviously, that's two decimal places here. I've got 410.05. That's two decimal places as well. And then 9.67412 has five decimal places. 5 decimal places is really great and precise and everything, but these first two only have two decimal places there, and so those will determine how our answer will be rounded. So what you want to do is punch this into your calculator or add it up just like I got it here by columns, and then we'll look at the answer that comes out of a calculator, for example, and we'll decide how to round it off. So I'm going to add these up real quickly: a 2, a 1, a 4, and then I got to bring down 5 plus 7 and carry my 1. That's a 12. Carry my 1. That's a 10. Right? Don't forget the decimal point here. So that's a 10. Another one here is a 2 and a 4. So when I add these all up, 420.22412. Okay. My answer, though, can't be 420.22412 when I actually give the official correct answer, because that number has far too many decimal places. Again, 0.50 has 2 decimal places. 410.05 has 2 decimal places. And that's the fewest. Okay, 2 decimal places here. 1, 2. 2 decimal places here. 1, 2. Each of those is the weakest number in the problem. This last one has 5 decimal places, and that's really precise, but it can't be that precise in our answer because not every measurement was that precise. And so when I round this off, I want to round off 420.22412 so that it has 2 decimal places, just like each of these first ones did. And so the second decimal place would be this second 2 here, and I want to round off to that position. So I'm going to drop all these last digits. Don't forget, though, to consider, will those digits round that 2 up to a 3, or will it stay as a 2? And of course, the basic rules of rounding that you've learned way back when apply. A 4 and down rounds this down, or keeps it as a 2. A 5, 6, 7, 8, 9 would round it up to a 3. So we don't have to round this one up. Our final answer would be 420.22. That would be your finished answer for that particular addition problem. Okay. So looking for the fewest significant figures that are in any of the numbers you start with will give you how to round your final answer. Same thing with my next example here. I have 0.080, 3 decimal places. I have 14. Now that has no decimal places. It's important to look for those numbers because often we forget that that can be our limiter, and it's going to be here. 9.35 has 2 decimal places. So I have 3 decimal places here. I have 0 decimal places here, and then I have 2 decimal places in my third and final answer. Well, the fewest, of course, of these is 0, the middle number. And so my final answer can only have 0 decimal places as well. So when I go to add this up, I'm going to round it off to look like that. So this 0 comes down. 8 and 5 makes 13. Carry my 1. 1 and 3 makes 4. I've still got a decimal point to watch for there. And then 14 and 9 make 23. So by the calculator, you're getting the same number off your calculator. The calculator will say 23.430 perhaps. Your calculator may not show that last 0. Either way, we need to round it off to be correct. And so in this case, to have the fewest decimal places would mean having 0 decimal places, which in this case would mean rounding 23.430 off so that it has no decimal places, rounding it off to the ones place. And this 4, of course, again, doesn't round me up. It leaves it as a 3. And so my final answer here would be 23. No decimal places, just like 14. That's my weakest number, or my least precise value, and so my answer can only be that precise as well. The same things apply with subtraction. So down here I have 14.50 minus 7.30. If I do the subtraction, same idea at the end. Each of these has 2 decimal places, so my answer should have 2 decimal places as well. 14.50, 7.30. When I subtract those, punch those into my calculator or do it right here on paper, I end up with, well, my calculator will tell me 7.2. Because calculators don't necessarily think in significant figures. And if your calculator gives you 7.2, that's okay and fine, but make sure that we round our answer off and have the decimal places reflect that each of these had 2 and 2 decimal places. Therefore, my answer must also have 2 decimal places. So I need to put that 0 back on, right? The calculator gets rid of it because that 0 is seen as extra and filling up the screen and maybe clutter, however calculator considers it. So we want to put that 0 back in so that our final answer has 2 decimal places, just like it should. You shouldn't have fewer decimal places than you're allowed, and you can't have more. So it needs to be exactly the correct number of decimal places. This is where a calculator isn't as smart as you necessarily, where we need to subtract, and in this case, actually add a 0 back on. Not round off, but kind of round on extra zeros to show those precisions that a calculator forgets and just drops off. So that's an introduction to addition and subtraction, how we would do that. You can go through and do more examples with what's here on the right side. There are 6 more problems here. So let's work out the answers to those 6 questions just real quickly here together, and you can kind of do a few with me, make sure you've got a pretty good handle on it. In the first example, 13.57 minus 6.3, we want to punch that in the calculator here, and when we do that, we get the answer 7.27. Well, since 6.3 has only 1 decimal place, then your answer should only have 1 decimal place as well. So we want to round 7.27 to have just 1 decimal place. So 7.27 becomes 7.3. 7.27, 2 decimal places. We're going to round that off to have just 1, 7.3. So your answer reflects the fewest decimal places that we found back here in 6.3. On the next one, 0.08990 plus 52. Well, obviously when we put that into a calculator, we're going to get 52.08990, which is what a calculator knows to give us for an answer. In the end, though, because 52 doesn't have any decimal places, there's none here, right, after the invisible decimal point, then your answer can't have any either. And so 52.08990 actually would need to round off to 52. And nothing after it. So in a sense, that 0.08990 didn't even matter. It was so small that it was insignificant. And that's an important idea as we move on to talking about significant figures. 63 plus 93 gives us 156 when we punch that in our calculator. 156 has no decimal places. Neither does 63, neither does 93. So 156 has no decimal places, and that's perfect. Okay, that works out great. A couple bigger problems here with 4 numbers to add together. Let's bring that calculator back up and punch that in. 25.37 plus 6.850 plus 15.07 plus 8.065. And our calculator tells us the answer is 55.355. Well, if we go back to our original numbers here again, 25.37, 2 decimal places, 15.07, 2 decimal places, and each of the others there have 3. So when we look at our answer, it needs to have not 3, but 2 decimal places. 55.355 we'll need to round to just 2 decimal places. So 55.355 would round to 55.36, and that's where that 5 rounds up, because the 5 behind it would round it up. Again, just general rounding rules. So 55.36 becomes our answer here. 55.36. Only as good as the weakest number in our series. To do our subtraction here, 0.9 minus 0.00005. 0.9 minus 0.00005 gives us this 0.89995 answer. Well, again, kind of like up here with the second example, because 0.9 only has 1 decimal place, our answer can only have 1 decimal place. And even though we are subtracting something from it, that something is so small that it really doesn't matter much at all. And so to round this off to have 1 decimal place, 0.89995 is going to round off to be 0.9. This 8 rounds up to a 9 because of the larger number behind it. And so your answer here, 0.9. In a sense, you did subtract something from it, but that something was so little that it didn't affect the overall answer. This is kind of like, I always say, someone like Bill Gates, who's worth $1 bazillion, right? Dropping a $20 bill. He's not suddenly worth 20 less than a bazillion, because that 20 to him is kind of insignificant. It wouldn't affect his net worth really that much at all. If I dropped a $20 bill, that'd probably be a pretty big deal. Maybe if you dropped a $20 bill, it'd feel like a pretty big deal. But when somebody like Bill Gates has so much money, $20 doesn't mean a whole lot. So it kind of depends what you're subtracting it from. In our last example, 4.37 plus 4.53, we get an answer of, from our calculator, kind of like in the example earlier, 4.37 plus 4.53, 8.9. Well, again, we want to make sure our answer has 2 decimal places. So this one does, so does this one. 8.9 from our calculator, we need to add that last 0 on there to show the precision, to show 2 decimal places, because we're required to have as many as the original value with the fewest. You shouldn't have fewer decimal places than you're allowed. You surely shouldn't add more than you're allowed. You should have exactly the number of decimal places that your answers, that your values permit you to have in your answers. So that's addition and subtraction. You'll have more practice. If you feel like you've got a pretty good handle on this, great. We'll go on to multiplication and division on the next video. Thanks.